That brings us to the next presentation in our series, and I'm very happy to present Matt Reid. I met Matt many years ago, and I've continued to meet him actually in academic conferences. But I got to know about his interest in the trucking sector at a meeting down in Liberty Mutual Insurance. And Liberty Mutual, as you probably know, is a very large insurance company in the United States. And they, based on their claims data, identified injuries in the trucking sector as very important to them. And so they put on a one-day workshop around getting in and out of trucks and working on catwalks for a number of groups within the United States. And at that meeting, Matt Reid put on a very interesting presentation about some of the findings that he and the group have been making around the design of trucks and how people get in and out of them. So I was very happy to be able to invite him to our workshop today. And so I'd like to introduce more formally Dr. Matt Reid from the University of Michigan Transportation Research Institute and the Center of Ergonomics to tell you a little bit about the work that's going on south of the border around ingress and egress and safety and ergonomics and MSDs.
Thank you. Thank you, Richard. And I want to thank the CRE-MSD and the THSAO. I've been practicing that. I really appreciate the opportunity to talk to this group. This presentation is going to be a little more researchy. I'm going to talk about the kinds of things that we're doing in the field and in the laboratory to get a better handle on this issue of ingress and egress injuries. As Professor Wells said, my appointments are at the Transportation Research Institute, which is primarily a safety-related research institute, and also in the Center for Ergonomics, where the work spans industrial as well as product-related ergonomics. The work that I've been involved in is mainly focused on the truck side, is mainly focused on manufacturers. As Professor Wells said, one of the challenges we have is that injuries to transportation workers and to drivers are multifactorial. That is, there are lots of different things that make a difference in whether someone gets injured and how severe the injuries are. But a really important part of the problem is the equipment. The design of the truck, the design of the components of the truck, the steps and the handholds really make a difference in the risk to the workers. Now, I've done a lot of work with the industry over the years, and so the focus of what I'm going to talk about here is on the design of the hardware. How can we make the hardware work better for the people who are actually using it? But there's also the training component of it, which comes in when we understand better how people are using it. So in the U.S., and I apologize that I don't have Ontario statistics or Canada statistics for you here, but in the U.S., like I think it is here, slips and falls for truck drivers and generally for transportation workers are a huge issue. It's a big deal that costs a lot of money, and it costs the people involved. Many drivers, I'll show you some statistics from a survey in a moment, many drivers, many transportation workers do get injured, and that has implications for their quality of life. From the best data that we have, we estimate that about 50% of the slips and falls that are reported in the U.S. happen on the tractor, in a tractor-trailer kind of situation, and most of those are on egress. It's just the physics of the situation that people are at greater risk when they're descending than they are when they're going up into the cab. And so this is where we're going to focus. Now, people wonder how the trucks get to be the way they are. There are some standards that are applicable, and these are widely followed in the industry. The Society of Automotive Engineers, which promulgates standards on a wide range of things, has minimum dimensions for the steps, how far they should be from the ground, how wide they should be, that sort of thing. And in the U.S., the Federal Motor Carrier Safety Administration is responsible for maintenance of commercial vehicles, and they have some requirements that apply particularly to high cab-over-engine trucks, which are considered to be among the most dangerous trucks for drivers because they're so high off the ground. And in the U.S., there's a military standard, 1472, that has more detail than these other standards do. And even though it doesn't apply to commercial vehicles, most commercial vehicle manufacturers pay attention to that standard because it has more information that they can use. One of the things I want to point out, the manufacturers I've found, the people that I work with, are starved for information on how they can make the trucks better. They know their problems. They hear from their customers, the fleets. They know there are issues, but they don't have the research basis to decide to go in one direction or go in another direction. And so then cost considerations tend to dominate. We're hoping to change that. So this is just briefly, some of the recommendations, and these all end up being pretty vague, but steps should be slip resistant. I'll show you some pictures of steps. I think you're all pretty familiar with the steps, at least on the vehicles that you're responsible for. They vary really widely. And one thing we don't have is a good standardized means to quantify what we mean by slip resistance. And maybe it actually needs to have different definitions depending on the environment. If you have an environment that has a lot of ice and snow, then that might constitute something different than in a construction environment where the primary consideration is mud. So there are these requirements, actually not exactly requirements. In the federal motor carriers, they're requirements. For everybody else, they're recommendations. But they end up not being very useful. So the central problem is that basically everybody's making trucks that comply with the available guidelines, and yet the trucks vary widely in the step and handhold configurations and generally in the configuration of their ingress-egress systems, and we still have lots of people getting injured. And that says that whatever we're doing, it's not enough. So what are the risk factors? We can't tackle everything at once, but we'd like to at least have a pretty good idea what the heavy hitters are, what the major factors are, and then try to tackle those. So weather conditions, when we look at detailed incident reports, we see that weather conditions are a major factor. As often ice, snow, mud accumulation on steps is a substantial issue. Footwear. This is something that doesn't appear to be very well controlled in the long haul industry. We've had some questions earlier in Professor Fraser's talk on the effects of diet, physical condition, that sort of thing. These are important. I'd add a couple others to there: training and its effectiveness, and also risk-taking. Some workers take more risks than other workers. The thing that I'm going to focus on, I draw your attention to that video there. This is a guy who was participating in a study. I'll show you some more results from this in a second. But here's a guy, he's a long-haul truck driver, and he is obese. He's wearing sandals. He's holding on with one hand as he's exiting the vehicle and facing outward, which he confessed was not the way he was trained to exit the vehicle. Is this an unusual event? No, not at all. So I'm going to describe some work that we are doing. This is work that's underway. We're about halfway into a 3-year program. The goal of this is to build the research base, to understand truck ingress and egress, and to develop some improved design guidelines. The focus here is on the hardware. It's to make the step and handhold configurations more uniform and better than they are now. But to do that, not by kind of seat of the pants guesswork, but by quantitative analysis. And in order to do that, we feel like we need to understand from a biomechanical perspective what drivers are really doing when they're getting in and out of trucks. How are they interacting with those steps and handholds? What are the forces involved? What are the motions involved, so that we can assess different systems in a quantitative way. So one of the key things that we want to be able to do here is to be able to assess the performance of an ingress-egress system for different kinds of drivers before the truck is even built. Those of you who are involved in vehicle design, if any of you are here, know that not just passenger cars and light trucks, but pretty much all vehicles are designed almost entirely in computers now. The idea is to reduce the number of physical prototypes as much as possible, but what that means is there's not much physical testing that goes on. In the case that we care about here, not much physical testing of people getting in and out of the trucks before the trucks start to come off the assembly line. So if a change has been made in a vehicle design that affects the steps and handholds, the manufacturers need to be able to address the safety of that in computer simulation. In order to be able to do that, we have to have a much deeper understanding of how people actually perform these tasks. So I'll just show you some pictures. You guys are familiar with this kind of thing, but there are a lot of steps. These are all pictures that were taken as part of this project at truck stops on Interstate 94. Interstate 94 is the main route between Chicago and Detroit. It carries a lot of traffic to Canada across the Ambassador Bridge to Windsor. These are just some of the different kinds of steps that show up. These are all tractor trailers. They're all what we call conventional cabs rather than cab over engine configurations. Lots and lots of different step configurations. These are all vehicles that are essentially performing the same service, and that says to me that these are not optimal systems. If these were optimal systems, they would look very, very similar because they're being used in the same way by basically the same people. The fact that they differ so much says to me that we don't yet understand how they should look. Handles the same way. There are interior handles. There are handles mounted on the exhaust system of the vehicle. This is actually a heat shield around the exhaust. There are external handles, the pretty typical handles that are usually rearward of the door. On the door, the handles are kind of all over the place. There seems to be very little standardization of where handles are placed. And I'll point out that there is value to standardization. When you get in your car and when you get in a rental car, when you get in somebody else's car, the controls are really very, very similar. Well, maybe the headlight switch is on a little different spot, but the steering wheel works the same way, the accelerator pedal, the brake. There's a lot of value for transfer of skills to having similar configurations. We don't have that in truck ingress-egress systems right now. Maybe you're lucky you have a fleet and all of your trucks are exactly the same, so your driver's going from vehicle A to vehicle B. Their training on how to get in and out safely transfers perfectly. A lot of drivers don't have that luxury. They are moving from vehicle to vehicle, and those vehicles are very different. Again, it says to me that we don't know how they should be configured, or they would be much more similar. So as part of this study, we went out to truck stops and videotaped drivers getting in and out. So this is a process where we approached drivers and asked them to participate. They had to sign the official University of Michigan consent form. And then we videotaped them and interviewed them about their experience. And the main thing I want you to see here is the extent to which these behaviors differ. If you watch the guy in the upper right-hand corner who's kind of interested, he knows that he was trained to exit the vehicle facing the vehicle, that is to back down out of the vehicle. This is what essentially all drivers are told to do. But you can tell he's not very experienced at it because he misses the handle one time coming out here. This is we didn't have any injuries during this videotaping, but there were some interesting events here. You can also see some things that look very awkward. People pivoting on the top step because they're used to getting out forward and then they think, oh, wait, backwards is the way I'm supposed to do that. These are not unusual sorts of things. It turns out there are lots of different tactics, and this is a critical thing that we've identified in our research. We can't design these systems for one tactic. The assumption, and Richard mentioned this Liberty Mutual conference, there were some representatives from the industry there, and one guy from Volvo, who I won't name, he stood up in front of us, and he was very explicit about the idea that everyone who drives a Volvo truck gets out backwards. That's the way they design the truck, and that's the way people use it. Well, we get videotape of people getting out forwards from Volvo trucks. But here's the thing. If you design it for only one tactic, then the people who are using that other tactic are not going to be adequately supported. So one of the key challenges is to recognize, yes, we want to coax people to use appropriate tactics, but we also want to support them if they are foreseeably using the product in a different way, as we would say in the automotive industry. So we also interviewed these drivers. We interviewed a total of 107 drivers, and these look a lot like, at least in the U.S., what the long-haul truck driver population looks like. Median age was 46 years. This is not a young population, with a substantial amount of experience as drivers. Very few women in the long-haul truck population. And our percentage of owner-operators, 13%, is pretty close to what it is in the U.S. But look at these numbers at the bottom, and this is self-report. You can think of reasons why it might be biased, high or low, but keep in mind, these are all people who are actively driving. So the people who have been injured and are no longer driving are out of this sample. 21% of them reported they had slipped or fallen getting out of their vehicle, so 1 in 5. And of those who slipped and fell, nearly half said that they were injured. Now, we know from the aggregate statistics that these are substantial problems, but here are active drivers talking about their experiences. By and large, they blame the steps. Now, we don't know if that really is where we want to focus our design attention, but the drivers at least blame the steps. Ground conditions also are a substantial factor. This was interesting for us, at least in this population, and these are people who were interviewed at an interstate truck stop, so these are by and large long-haul drivers. The percentage of them that had fallen or been injured from anything other than getting in and out of the cab was substantially smaller. So if you had a different delivery service or something where ingress-egress happens a lot more, people loading packages, unloading things, these numbers might be different. But in this population, egress was the main factor, and the steps were implicated. When we designed this study, we recognized that when we show up at the truck stop with a video camera, we are changing the behavior of the drivers. As soon as we start talking about getting in and out of the truck, we're changing their behavior. So we're affecting what we're trying to monitor. So we designed the study such that we would have this detailed interaction with the driver and also a substantial amount of covert observation. So we trained a couple of graduate students to be able to watch a person getting in or out of a truck and accurately code what they were doing with their right hand, what they were doing with the left hand, right foot, left foot. And it turns out there are about 5 or 6 main ways that people get out of the truck, and they can identify those very quickly, could validate that against video. And I'll just point to a couple of key results here. These are same kinds of truck stops on the interstate, just they didn't know they were being observed. So on the video on the left side, you can see that 68% of the time, the drivers were facing the truck. This is what the drivers are told to do. They're told to maintain 3 points of contact. They aren't usually told what that means, but they're told to maintain 3 points of contact, and they're told to face the truck, getting in and getting out. Well, 2/3 of them basically did that when we were videotaping them. Only 18% were facing out, and a substantial number of these switching sorts of situations occurred where they kind of got themselves out of the truck and then shuffled around so that they could back down. But there's a big number there. Half, essentially, in the covert observation, got out of the vehicle facing away from the truck. The reality is people do not, on average, back down out of the vehicle. But there's some other scary stuff going on here. You look at the asterisks down there, jumping from the first or second step almost 5% of the time. No hands at all in 1 in 10 of these covert observations. And then carrying something in the hand is also something very frequent. And the problem there, maybe the other hand is being used, but if a slip occurs or a trip occurs as they get out, their options for saving themselves from the fall are greatly diminished if they're carrying something in the hands. So from the covert observation, we have some more detail about what people are really doing. So a big piece of this work is the laboratory. We need to understand from a biomechanical perspective what people are doing. What are the forces? What are the moments from a quantitative perspective? So we've built this mock-up that you can see here. There's a little movie there where you can see how we can adjust the steps back and forth and up and down. And we've put force plates, force measurement equipment all over this mock-up. We have just, in the last couple weeks, started data collection on this. And I can show you a little bit of what this looks like. Here's a truck driver. This is an experienced guy. He has 23 years of truck driving experience, I think. And that get-up he's wearing, no, that's not what he normally wears to drive. Those are his normal boots, but the rest of it we provided. Here's the thing. In order to be able to do this analysis, we need to have very detailed information about how he's moving. And we do that with a technology called optical motion capture. If you look closely, you can see he has little reflective balls taped all over his body. And what you see on the right is what our camera system picks up from those balls. So he's performing the motion relatively unencumbered, but what we're getting is very accurate and precise detail about how he's performing that motion. And we can analyze that in 3 dimensions. And we have more information than we're showing here because underneath each of those steps, you can kind of see it here, there's a force plate. So we know exactly how much force he's applying to the steps and in which directions. And that's critical because we need to understand what would happen if he lost a grip, for example. If something unusual happened, and that's a key thing to think about. It's not the normal behavior that we're concerned about typically. There are some issues about sort of cumulative load, particularly for people who are getting in and out all the time. But in this particular population for long-haul drivers, we're mostly worried about acute injury. And there we want to know what's going to happen in the exceptional situation where he steps down, only there's ice on that step. What are his chances of being able to support his body weight with his hands? That's the kind of thing we can understand from the biomechanical data. And as I said, we want to use the biomechanical data to be able to simulate this in computer software, to be able to simulate drivers with different body sizes getting in and out. So I'm going to conclude with some observations and leave some time for questions and answers. Let me address some of the things that are burning for you. And I invite you to compare these observations to your own experience with your fleets. Everybody is doing the job a little bit differently. Everybody has different equipment, different kinds of risk factors, but I think these apply across a pretty wide range of vocations in the transportation sector. In our data with long-haul drivers, about half of them are exiting facing outward. And sometimes this comes as a shock to safety people at fleets because they spend so much time training their drivers that you're going to get in and out facing the truck with 3 points of contact. It's not happening when they're away from the depot. One of the reasons is that getting out facing the truck is really complicated from a motor coordination standpoint and critically from a vision standpoint. What we see is that a lot of drivers are pretty big in the midsection. In the U.S., over half of truck drivers are obese, which is defined as a body mass index over 30, which means for basically a 5'9" guy is over 200 pounds. That's what we're talking about. Most truck drivers in the U.S., and that category includes people who do local delivery and lots of other things. In the long-haul sector, it's more than that. These guys have a really hard time seeing past the belly. And so in order to get out facing the truck, they have to look out, find a place to put their foot, stand up, look down past their body to find where to put the next foot. And it's just hard to do that. And you saw some of the results of that in our videos there. So what do we do about that? Well, a couple of things. I think that we need to recognize, first of all, they're not necessarily going to do what we tell them. There are quite a few trucks that are not designed to support a safe egress facing away from the truck. If you're facing the truck, the handholds are there, everyone should be able to reach them. But turn around, the handholds are no longer accessible. And that's a reality that we have to try to address in the design. I mentioned before that the wide range of configurations in the real world suggests to me a lack of optimality. There's a lot of work to do there. One of the kinds of information that we need is the experience from fleet operators, which is to say people who've been doing this for a long time have accumulated a lot of knowledge about what really works and what doesn't work. For example, I've heard from people that they don't like steps that have a very sharp edge on them. The sharp edge on it looks pretty good for ingress, but the concern is that it's a trip hazard for egress. So that's the kind of information that we can then go into the laboratory and try to validate with people with our measurement equipment. So for us, getting the perspective from people who are in the field and are seeing the injuries happen and trying to understand why they happen and prevent them, that's useful information from us. We need to develop some assessment procedures that are valid. So, and again, this work is still very much underway. We will have a lot more detail in our recommendations, but just from the stuff that we've seen, I think We should keep talking about 3 points of contact. People don't do it. If you've tried to get out of a truck quickly, because it's your job, with 3 points of contact, it's pretty darn hard, because basically it means you can only move one limb at a time, and not very many people are actually doing that. I think we can go beyond 3 points of contact and face the truck, recognize that people are going to do other things, and try to train them to do those things, not tell them to do that, but try to tell them other things that can make that safer. So, not carrying objects in and out of vehicles. This is challenging. People have logbooks, they've got their lunch. Providing a way and just educating people about the idea that there is a way to get in and out of the vehicle without having to carry something in their hand, freeing that hand up to grab a handhold. That's something we can do. Jumping happens. These people are at high risk of injury. Even if they don't slip and fall, it puts their low back particularly under a lot of strain. That's something that needs to be addressed, I think. And there's another aspect, which is check before you get out of the truck. When you look at incident reports, you see a substantial number of them that involve some kind of a slippery surface. And just if we can try to get that into drivers' heads that they should do that, the guys who've been doing it for a long time, the guys who've been driving for 30 years without getting injured, they know that. Getting that information to the younger drivers is probably important. And two other things. Footwear. I think footwear makes a lot of difference. One company, again at this Liberty Mutual seminar, reported a significant reduction in slip and fall injuries when they issued footwear to their drivers. They went ahead with the expense of providing footwear that provided good slip resistance and encouraged their drivers to wear that footwear, and they got a benefit out of it. They believe that that was a substantial return on investment. And maintenance. This is the responsibility of the companies to make sure that that equipment is maintained. We see lots of steps that are worn down where the slip resistance is gone, especially in situations where there's a lot of mud and grit. So we're going to keep working on this stuff. We think that these research methods, this sort of biomechanical approach, is also applicable to other sorts of things, getting on and off trailers, tarping, which you saw Professor Fraser talk about. There are lots of other things that are challenging besides getting in and out of the truck. But the research methodology of trying to understand in a very detailed way what people are really doing, what their tactics are, and what the resulting loads on the body are, what those forces and moments are. That's going to be really important to addressing those things. So, thanks for your attention. If you need more information, you will have this presentation, but if you need more information, feel free to contact me. Thank you.
Thank you very much, Matt. We have time for a couple of quick questions. We have a question at the back.
Syed Naqvi from Occupational Health Clinics. Based on my experience, I've dealt with a few truck drivers who have complained of knee pain. In your experience, have you looked at instead of 2 steps, 3 steps? Because, for some people, 2-step is just too high, especially if they are shorter, and they have complained of a lot of knee problems as a result of 2 steps. So have you seen any studies that tested more than 2 steps?
One of the things that we're going to investigate is the way that the loads on the body change if you vary the height of the steps. So briefly, the problem with 3 steps is that it's too small for most people, and they will skip steps. And so effectively, you are increasing the amount of range that most people will use. But another really critical thing is that the step configuration, the effects of the step configuration on the musculoskeletal loads varies with tactic. So those movies I showed with people getting out forward versus getting out rearward, the joint moments, that is that contributor to stress at the joints, is substantially greater facing forward. Essentially, people are falling and trying to catch themselves with their knees as they're going out. So the same a configuration that might be acceptable for a rear-facing egress strategy, or sort of facing the truck egress strategy, might produce, well, in our preliminary data, does produce higher loads when someone's facing away. So the solution there Could be a change in step configuration. Depends very much on the vocation issues and who the population is. But it also could be a change in tactics. I know people like UPS have focused a lot on egress tactics to try to reduce load. So both those things could come into play.
I have a question. Just wondering if there has been any studies or research made on ingress or egress on the cargo boxes or the flatbeds of trailers?
Yeah, there has been work done on that, and in fact, I think that there's some work at Waterloo looking at that. The challenge there is trying to characterize what I'll call parameterize the problem well enough. So in order to really understand it, we've got to be able to characterize what people are doing. And one of the challenges with getting on and off the trailer is there's so many ways to do it, and there's so many different kinds of trailers. That is our next phase, to start looking at that, looking at hooking up for tractor-trailer operators, looking at those kinds of operations. So those are critical. And I'll just give you one example. Getting in and out of box trailers is something that happens a lot. And there are all kinds of aftermarket kind of solutions for that. Ladders that stow under the trailer, for example, various kinds of handholds and things. But what the people from the fleets tell us is none of that really works for them because of the conditions of service. So as soon as somebody backs that trailer into a loading dock and breaks off the handle, it's no longer functioning. If they stow the ladder underneath the trailer, either the driver doesn't use it or gets in just fine, and then the ladder's not there when the critical getting out happens. So those are important problems that need further research.
Has there been any studies about steps perpendicular to the vehicle as opposed to parallel to the vehicle? Like on heavy equipment, and I know bulldozers and that sort of thing, they often use a regular step ladder kind of thing.
Yes, in fact, Freightliner, a big company developed for its Argosy cab over engine, real high cab over engine configuration, developed what essentially is a staircase that pivots out when the door is opened. I'm not sure they ever sold any of those. So there are two critical issues, and the one real important one is overall width. On-road trucks are constrained in overall width, and they use every bit of that, 102 inches or so, and it's getting the steps with any offset at all is often a challenge. And the more stair-like configurations, longitudinal with the truck or perpendicular to the truck, often there's not enough space to do that, some of the constraints. But there's an interesting aspect of that, which is we think that step configurations that are more like stairs encourage people, that is, better support an outward-facing egress, which we also don't think is as safe as an inward-facing egress. If we build the steps so that they're basically like a ladder, everyone will get out facing the truck, essentially, the people who don't jump. And yet we don't really think that's the safest way to do it. We think some offset is important. So there's two things. The perpendicular or longitudinal with the truck, sort of walking up the stairs, doesn't really work in a non-highway application because there's not enough space. But the other issue is it might not actually be safer if the behaviors that step configuration produce are not themselves safer. So it's kind of both those pieces there.
I'm going to have to cut us off here. I'm sorry. Lots and lots of good questions that could come from that, and I really encourage you to corner Matt and not let him eat his lunch and get maximum information from him. So certainly ask him about what's the most important part of a step when you're judging its slip resistance. Something I learned is kind of interesting. So thank you very much, Matt.